Hello everyone, today we're going to do inverse functions. We have covered inverse function in chapter 5. So today's lesson is all about revision and a little bit about restricting the domain so you can find the inverse function. Alright, so here's some key points. I just want to refresh your memory. So what is the inverse function? So the graph of the inverse function can be obtained by reflecting the original graph in the diagonal line y equals to x. That's a very important concept here. And later I'm just going to show you how to sketch an inverse function from the original graph. Okay, so that's the first key point, very important. The graph of the original function, the graph of the inverse function is obtained by reflecting the original graph in the diagonal y equals to x. The next key point is an inverse relation. An inverse relation of a given relation is a function if and only if no horizontal line crosses the original graph more than once. So this is really important. I usually just call that this is the horizontal line test. Okay, and I would like to show you later what does that mean. Okay, so any function or any relation that passes the horizontal line test, then if you try to get the inverse of that relation, it will be the function. All right, it will be a function. All right, so the next point is the domain and the range of the inverse relation are the range and the domain, okay, respectively of the original function. Okay, so they just simply switch the position. So the domain of the original function becomes the range of the inverse function, and same applies to the range. So the range of the original function becomes the domain of the inverse function. So if you think about, we have the original function, fx, and then we have the inverse function, f inverse x. Then the domain of this function and the range of the original function will be, just switch the position. So that will be the domain here and range. So as you can see, the domain of the original function becomes the range of the inverse function, and the range of original function becomes the domain of the inverse function here. All right, so this is very important. All right, so now I would like to talk about, these four type of relations: one-to-one and one-to-many, many-to-one and many-to-many. And then from here, I'd like to just give you a summary. What happens if the original relation is a function, and if the function is one-to-one, then what is the relation? What would be the inverse? All right, is that going to be a function as well, or is that going to be a relation? Okay. Okay, so the first one, let's just start with one-to-one. All right, so one-to-one. What's one-to-one relation? So for every x value, there's only one y values, and that would be the one-to-one relation, or we can call that a function. All right, so here's an example. That's one-to-one. All right, one-to-one relation, but it is a function as well. Okay, and if we just draw the horizontal line, okay, anywhere, all right, if we just draw a horizontal line, as you can see, that horizontal line only touches the graph at one single point, no more than 1 point. So therefore, this one-to-one relation can be turned into an inverse function. Okay, firstly, this is a function, and then it will have an inverse function as well. Okay, so this will have an inverse function without restricting the domain. All right, so the next one is many-to-one. So many x values to one y values. And this is what a graph will look like. So like, for example, just a parabola. X and a y. So many x values give you one y values. Now, this is a function again. All right? It is a function because it's past the vertical line test. However, if you draw a horizontal line, as you can see, that horizontal line touches the graph at 2 points. So basically, it failed the horizontal line test. So therefore, if you try to turn this many to one function into inverse, then you're not going to get an inverse function. You're going to get an inverse relation. It is not going to be an inverse function unless you try to restrict the domain, which is the whole point of this exercise. Like how do I restrict the domain so this function can be turned into an inverse function instead of inverse relation. Okay, and later I would like to show you how to do it. All right, so one-to-one function and many-to-one function. We'll only talk about these two first, okay? And in the future lessons, I will talk about what happened to one-to-many and many-to-many relations. Okay, all right. So let's try an example here. Okay, let's try the first example. So the first example I'd like to give to you is it is going to be, I think it's just going to be a function, and then you just want to find out what is the inverse and show that inverse is a function, it's not a relation. Okay. So the first question here, example 1, the question says write down the inverse relation. We still call that inverse relation of fx equals to x minus 2 over x plus 2. Okay, x minus 2 over x plus 2. Okay, all right, so how do we do this? The first step is, if you want to find the inverse of a function or inverse of a relation, then the first step is you change x to y and then you change y to x. Okay, so the first thing I will do is I'm just going to let y equals to x minus 2 over x plus 2. Then the inverse relation is going to be, so I'm just going to change this y to x, and then change all the x's to y, so that becomes y minus 2 over y minus y plus 2. All right, so that's what we do. So change this x and x here to y and y. So I'm just going to use different color. Okay, so after you finish that, then the next step is you definitely need to make y as a subject by rearranging everything, making y as a subject, so hopefully you can see if it's a function or if it's a relation. Okay, so let's just cross multiply. Let's multiply this x, y plus 2 is equal to y minus 2. So xy plus 2x is equal to y minus 2. Keep doing it. Move the y to the left hand side. Factorize the y out. And here we go. Alright, so that's the answer here. Now, if you don't like the format, what you can do is to remove the negative on the top, alright, and then it becomes 2x plus 2, and then switch the denominator. Okay, so switch the denominator from x minus 1 to 1 minus x. So that gives you the answer there. Now, as you can see, there's only one solution for y, and we can assume that this inverse relation is a function. Alright, so that is a function. We don't need to restrict the domain at all, and yeah, that's all. So as you can see, that is a function, and this is a one-to-one function. If you try to sketch this original function here, it is one-to-one function. So therefore, the inverse relation of this function will be a function as well. Okay. All right. Now, the second part of this question will ask you to show a very important property. Show that f inverse fx is equal to x. Now, when we're talking about inverse function, there's a very important relationship between the composite function of inverse function and the original function. If a function is an inverse function, then this is equal to f inverse x is equal to x. Okay, it's a really important feature here. So if fx is 1-to-1, then the inverse of y equals to fx is also the function. So we can write down a y to the power of -1x. Well, actually, this is not reciprocal. That's just called the inverse function x. And then the composition of the function and its inverse in either way or in either order is an identity function, which leaving every number in their domain unchanged. And then as you can see, they're both equals to x. So what we need to do is to prove that this is equal to x. All right, so how do we prove it? So let's just write down what's fx first. All right, so fx, which is the original function, the original function is x minus 2 over x plus 2. X minus 2 over x plus 2. And then let's write down what's f inverse x. The f inverse x is the answer we get from the previous one. All right, so that's what we get. What we need to prove now is we're going to prove that f inverse fx is equal to 0. Is equal to x. All right, so let's prove it. So f inverse x, that's f inverse x. So we need to write down f inverse x. But we need to replace this x by everything here. So basically we're going to substitute everything inside. So it's not going to be a nice and an easy algebra to do, okay? So we're going to get 2 brackets x minus 2 over x plus 2 over 1 minus x minus 2 over x plus 2. All right, so all we need to do is try to simplify this, a fraction. Hopefully the answer is equal to x. All right, so let's expand to x minus 2, x plus 2 over 1 minus x minus 2 over x plus 2. After you finish up to here, what you can do is multiply both the numerator and denominator by x plus 2, so you can get rid of the fraction. All right, just a bit easier. So that gives you 2 brackets x minus 2 plus 2 brackets x plus 2 over x plus 2 minus x minus 2. All right, I hope after I simplify everything, the answer is equal to x. All right, so the numerator is 2x minus 4 plus 2x plus 4. And the denominator is, after we cancel these 2 out, the denominator is just equals to 4. Okay, just equals to 4. All right, so let's have a look at the numerator. We can carry across these 2 out. So we get 2x plus 2x, which is 4x. And a 4x divided by 4 is x. So we just proved it is equal to x. So that's one of the important feature when we're talking about inverse function here. So you do need to know how to do this type of question properly. Okay, so what you can do is you can definitely try the other one. So you can try to show that f bracket f inverse x is equal to x. You can actually show this one. All right, I'm not going to do it, but you can try this one and just see if that's also equals to x. And that's the reason why the inverse function and the original function are just a mirror reflection about the line y equals to x. Because if they do intersect each other, they're going to intersect on y equals to x. Okay, all right. Now we're going to do an example where you need to restrict the domain of the original function, because otherwise it's not going to be a function, an inverse function. It is going to be an inverse relation. Okay, so an example 2. So let's just have a look at this one here. Y equals to x minus 2 squared. Let's just have a look at this original function. That's the original function. All right, let's sketch this original function. X minus 2 squared. All right, this is a parabola, right? So it will be a parabola. That's 4. Here's 2. And the turning point or the vertex will be on the x-axis. All right. Now, let's pay attention to this. If you try to do a horizontal line, as you can see, that horizontal line touches the graph at 2 points. All right, so the horizontal line test, all right, is not going to work. So horizontal line test failed. All right, so what do we do? If the horizontal line test is not working here because of, this is not a one-to-one function, it is many-to-one function here. So if we try to find, or if we just do the inverse of that function, you are not going to get an inverse function. So you're not going to get an inverse function, you're going to get an inverse relation. All right, so I'm just going to show you how to do that, okay? So if we were to use the line here, that's y equals to x. All right, remember this is the mirror reflection line, y equals to x. And then if you try to do the inverse of that function, you're going to see that this is what you're going to get. Let me draw that. It's not a very nice diagram, okay, sorry about that. I tried to make the diagram a bit easy for everyone to see, but this is a terrible, terrible diagram. Really ugly. Okay, all right, so I hope I can draw a better one. All right, this is the best I can do, just because my scale is not really correct, and I try to make sure that this point is actually intersect on this line, but this is not a very nice diagram, sorry about that. But you know what I mean, right? This, as you can see, the relation in red is not, it's not a function, right? The graph in red is not a function at all. It's a relation, because if you draw a vertical line test, it is going to touch the graph at 2 points. So what we need to do is we need to restrict the domain. Okay, we need to restrict the domain of the original function, so we can draw a proper, inverse function. Okay, so what I would do is I'm just going to clear all of this. I'm just going to redraw the diagram so we can restrict the domain of the original function. Okay, so let's start one more time. This time I'm just going to draw a big diagram. That's x, that's y, here's 4, that's 2, and this is the graph here. Unfortunately, this is still not quite right, okay? All right, let's call this as 4. All right, now, how do we restrict the domain? There is no specific rule that tells you you need to follow this particular rule to restrict the domain. All right? Basically, you restrict the domain so you only have a part of the graph that's follow the horizontal line test. All right, so it becomes a one-to-one function. Okay, all right. So what I can do is, if you think about it, you can restrict the domain by just choosing this part. Okay, let me just show you. This part of the function. All right, just this part of the curve. And you're removing the other part of the curve here. So don't worry about this part of the curve. All right, remove this part of the curve here. So you only choose that part. So let's just change that to dotted curve. Now, if you draw a horizontal line, you will see the horizontal line pass. All right, the horizontal line test pass, because that becomes a one-to-one function. All right, so if you pay attention to the domain here, the domain is x is greater than or equals to 2. So this is really important. So here we go. The domain of this original function is x greater than or equals to 2. And let's write on the range first. All right, the range will be y greater than or equals to 0. Because this information, we're going to use it to find the domain of range of the inverse function. All right, so let's find the inverse of that function. So y equals to x minus 2, that's the original function. We're going to find the inverse function. And remember the domain is x greater than or equals to 2, because if you don't provide me that domain, I don't know, I can't find the inverse function. It will be an inverse relation. All right, so let's change y to x, change x to y, and you get that. And then let's square root both sides, you get square root of x. And you have to put plus minus. That's very important. All right, now rearrange this, making 2 to the right-hand side. You get 2 plus minus square root of x. Now here comes the very interesting, formula. You've got two sets of formula. Y equals to 2 plus square root of x, and y equals to 2 minus square root of x. The reason you have two formulae like this is just because of you do have two parts. Remember I told you before that when you sketch the inverse of that, you're going to have to, you're going to have a relation. It's not a function unless you restrict the domain, right? So the inverse of that function will look very similar to this. Okay, so you only have the top part, all right, not the bottom part. So that's the bottom part here, but we're only looking at the top part. All right, now how do we check? How do we know which one is the inverse? All right, according to this domain here, which one is the inverse and which one is the range? How do we know? We look at the actual domain. The domain of the original function is x greater than or equals to 2. So that means the domain and the range of the inverse function will be switched around, right? So the range of this will be y greater than or equals to 2, and the domain of the inverse function will be x greater than or equals to 0. They just switch around, all right? So have a look at here. All right. So from this range here, y must be a number that's greater than 2. Okay, so how is that possible y is greater than 2 or equals to 2? Well, this is the only correct equation for y equals to 2 plus square root of x. So the y value is always greater than or equals to 2 because square root of x is always greater than or equals to 0. So therefore, that would be the equation of the inverse function. So you have to pick the right one. Now, of course, if you ask me, can I restrict the domain so the domain is x less than or equals to 2? Can I just do the other part of the function, like for example, this part? All right, and then find the inverse function. Yes, you can. All right, you can do that. That just means you are using that formula for the inverse function. So it does depend on which domain you choose for the original function. How do you restrict the domain of the original function? Then the inverse function will be slightly different, okay, in terms of formula. Again, there are no particular rules for which restriction should I choose. No particular rule. Usually we just look for the stationary points or the turning point, if possible, and then we break down the graph from the stationary point, and then usually it will be probably helpful to choose a domain that includes zeros, but it's again not necessary true all the time. So there is no particular rule, as long as you remember the part of the function that you're choosing here must be a one-to-one function, so the horizontal line test is going to pass. Okay, that's what we're going to do. Okay, all right. So yeah, that's all I want to teach you about restricting domain. So it's almost everything is a revision, apart from just the restricting the domain part that you do need to pay a bit of attention, but the rest of them are just revision for you. Yeah, thank you.